China and Russia plan nuclear power plant on the Moon, a new era in lunar exploration.
On April 23, 2025, Pei Zhaoyu, the chief engineer of China's Chang'e 8 mission, announced significant developments in the ambitious plans for the International Lunar Research Station (ILRS) during a presentation to international stakeholders. According to Pei, China and Russia are collaborating to build a nuclear power plant on the Moon aimed at supporting the ILRS, which is intended to establish a permanent human presence on the lunar surface. This initiative is a crucial component of China's broader lunar exploration strategy, which includes launching the Chang'e 8 mission in 2028 as a precursor to a fully operational lunar base by 2035.
The need for power, challenges in lunar exploration.
Energy supply has been identified as a critical challenge for the ILRS, which will be located in the Moon's harsh environment. Pei emphasized that a reliable and sustainable source of power is essential for the station's operations. While various energy alternatives are being considered, nuclear power emerged as a prominent option. Wu Weiren, chief designer for China's lunar missions, highlighted Russia's advanced capabilities in space-based nuclear technology, which could play a pivotal role in the success of the ILRS.
Timeline of development. The timeline for this ambitious project outlines several key milestones. 2024, Russia's space agency Roscosmos announced its intentions to collaborate with China on the construction of a nuclear reactor on the Moon, targeting completion by 2035. 2025, Pei Zhaoyu's presentation confirmed the nuclear power plant plans and showcased strong governmental support from China for this joint endeavor. 2028, scheduled launch of the Chang'e 8 mission,
which aims to lay the groundwork for the lunar base and explore potential energy generation methods on the Moon. 2030 to 2035, target for establishing a permanently staffed lunar base at the Moon's south pole, enhancing humanity's presence beyond Earth.
International context and competition.
The China-Russia initiative unfolds amid a global race in space exploration, particularly with the United States NASA leading the Artemis program, which aims to return astronauts to the Moon by 2027.
NASA plans to deploy solar power systems for its lunar base, creating intense competition for resources and technological advancement in lunar exploration. The timelines of both the ILRS and NASA's Artemis program align closely, with each nation striving to establish a foothold on the Moon. Potential benefits and resource utilization. The Moon is believed to harbor vast resources, including rare earth metals and helium-3, an isotope that could potentially serve as a fuel for nuclear fusion, promising to meet global energy demands for thousands of years. Establishing a nuclear power plant on the Moon could facilitate extensive operations in space and mark a new era in human exploration beyond Earth. The presence of such a facility would enable sustained energy generation, crucial for supporting long-term lunar missions and research. Strategic implications. The collaboration between China and Russia on the lunar nuclear reactor not only highlights advancements in space technology but also underscores the strategic importance of lunar resources. As nations race to secure a presence on the Moon, the implications for international collaboration and competition are profound. The establishment of the ILRS is expected to foster partnerships among various countries and scientific institutions, potentially leading to new discoveries and innovations in space exploration. Conclusion.
The plans for a nuclear power plant on the Moon by China and Russia represent a significant milestone in the quest for sustainable energy sources in space. As the Chang'e 8 mission approaches its launch in 2028, the collaborative efforts of these nations will likely shape the future landscape of lunar exploration and international relations in the context of space. This initiative not only reflects the technological capabilities of both countries but also emphasizes the strategic importance of lunar exploration in addressing global energy demands and advancing humanity's presence in the cosmos. As these plans unfold, the world will closely watch how this new chapter in space exploration develops, potentially paving the way for unprecedented advancements and discoveries. The proposition of a nuclear power plant on the Moon is articulated by Chinese and Russian officials,
showcases several counterintuitive elements that challenge conventional wisdom about lunar exploration and energy solutions.
1. Nuclear power as a viable option in space. Traditionally, nuclear energy has been viewed with skepticism, particularly in public discourse where safety concerns dominate. However, the Moon's harsh environment, characterized by extreme temperatures and prolonged periods of sunlight and darkness, makes solar power impractical as the sole energy source. The idea that nuclear power, often associated with risks, could serve as a stable and reliable power source for lunar operations is counterintuitive. This perspective is further supported by the assertion that Russia holds a leading position in space-based nuclear technology, suggesting that what is typically considered a terrestrial risk could be transformed into an essential tool for extraterrestrial energy needs. 2. International collaboration as a strategic imperative. The collaborative approach between China and Russia in the face of geopolitical tensions may seem unexpected. Given the competitive nature of space exploration, particularly with the U.S. re-engaging with lunar missions through NASA's Artemis program, one might anticipate a more isolationist or competitive stance from these nations. Instead, their partnership underscores a strategic vision that prioritizes shared technological advancement over national rivalry, challenging the narrative that space exploration is a zero-sum game. 3. Resource utilization versus environmental concerns. The Moon's potential as a resource hub, particularly with references to helium-3 and rare earth metals, presents a paradox. On Earth, the extraction of such resources often comes with significant environmental costs and ethical considerations. However, the prospect of exploiting lunar resources for energy generation raises questions about the sustainability of extraterrestrial mining practices. The notion that humanity could extract resources from the Moon while simultaneously seeking to protect Earth's environment contradicts the prevailing narrative about conservation and sustainability. For long-term human presence in space, the ambition to establish a permanent human presence on the Moon by 2035 takes on a counterintuitive aspect when one considers humanity's historical challenges with long-term habitation in extreme environments. The leap from temporary missions like those during the Apollo era to a sustained lunar base challenges assumptions about human adaptability and technological readiness. The implications of a permanent lunar base also raise questions about the feasibility of maintaining life support systems, psychological well-being, and the socio-political structure of human settlements beyond Earth. 5. Perception of space as the new frontier. The initiative to build a lunar reactor reflects a paradigm shift in how space is perceived, not merely as a destination for scientific exploration but as a new frontier for energy independence and geopolitical influence. This understanding contrasts sharply with the historical view of space as an inhospitable realm devoid of resources. The idea that nations could vie for control over lunar resources challenges long-held beliefs about the limits of human expansion and the potential for cooperation in the face of shared challenges. 6. Technological feasibility versus public perception. The proposed nuclear plant's construction implies a level of technological advancement that may not align with public perception of current capabilities in nuclear technology, particularly in the context of space. The public's skepticism towards nuclear power often stems from historical accidents and the complexity of nuclear technology. Yet the assertion that such a project is feasible within a decade suggests a disconnect between technological progress and societal acceptance, highlighting the gap between what is possible and what is publicly accepted. 7. Global competition versus collaborative advancement. The competitive landscape of lunar exploration, particularly with the U.S. aiming for a sustainable lunar presence by 2027, paints a picture of rivalry. However, the simultaneous pursuit of collaborative projects like the International Lunar Research Station (ILRS) illustrates a nuanced reality where nations recognize that collaboration can yield more significant advancements than competition. This strategic cooperation contradicts the notion that nations must act solely in their self-interest, suggesting a more complex interplay of competition and collaboration in the space sector. In conclusion, The plans for a nuclear power plant on the Moon by China and Russia not only represent a significant technological endeavor but also challenge numerous assumptions about international relations, resource utilization, and human adaptability in space.
These counterintuitive aspects reveal a rapidly evolving landscape in space exploration where traditional paradigms are being reconsidered in light of new possibilities. The recent announcement regarding China and Russia's plans to build a nuclear power plant on the Moon for the International Lunar Research Station (ILRS) presents several significant aspects that are easily overlooked yet crucial for understanding the broader implications of this development. 1. Technological collaboration and nuclear expertise. The partnership highlights Russia's advanced capabilities in space-based nuclear technology, which could potentially surpass that of the United States. This aspect is often overshadowed by the focus on the Moon's resources or geopolitical competition. The significance lies in the fact that Russia has a historical advantage in nuclear technology stemming from decades of investment and research, particularly in the realm of space applications. This collaboration may enable China to accelerate its lunar ambitions and potentially reshape its technological landscape, granting it access to expertise and technology that may otherwise be challenging to develop independently. 2. Strategic timing and geopolitical implications. The timeline for establishing a nuclear power facility on the Moon aligns closely with the U.S. NASA Artemis program, which aims to return astronauts to the lunar surface by 2027. This timing is not merely coincidental, it reflects a strategic maneuver in the ongoing space race. The establishment of a permanent lunar base by 2035 would provide China and Russia a significant foothold on the Moon, potentially allowing them to claim rights to lunar resources and influence future international governance in space. This aspect is critical because it underscores the growing importance of lunar resources in global geopolitics, particularly in the context of energy and technology competition. 3. Resource utilization and economic incentives. The Moon's potential resources such as helium-3 and rare earth elements are frequently mentioned. However, the implications of these resources for future energy demands and economic stability are often downplayed. Helium-3 in particular could provide a clean energy source for nuclear fusion, which could revolutionize energy production on Earth. The significance of this resource cannot be overstated, as it could lead to a paradigm shift in how humanity approaches energy sustainability and dependency on fossil fuels. The race to secure access to such resources signifies a new frontier in economic competition, one that extends beyond Earth and into space. For long-term sustainability of space operations, the focus on nuclear power as a reliable long-term energy solution for the ILRS points to a broader trend in how humanity plans to engage with space environments. Traditional energy sources like solar power, while effective, may not provide the consistency required for sustained human presence on the Moon, particularly during lunar nights which last about 14 Earth days. The emphasis on nuclear energy indicates a shift toward acknowledging and addressing the challenges of long-term sustainability in extraterrestrial environments. This insight is significant because it reflects an evolving understanding of what is necessary for human survival and operational efficiency in space. 5. International collaboration in space exploration. The ILRS project, which aims to involve numerous nations and scientific institutions, represents a shift toward more collaborative approaches to space exploration. While the U.S. has historically dominated lunar exploration, the involvement of multiple countries in the ILRS could foster a more inclusive framework for international cooperation. This aspect is significant as it may lead to new norms regarding the sharing of technology, scientific knowledge, and resources in space, potentially mitigating conflicts over territorial claims in a domain that has traditionally been seen as a national priority. 6. Cultural and scientific advancements. The Chang'e 8 mission and subsequent projects are not solely about infrastructure, they also represent a cultural and scientific leap for China and its partners. The potential for international collaboration on scientific research in lunar geology, astrobiology, and technology testing could pave the way for breakthroughs that benefit all of humanity.
This aspect is often overlooked in favor of geopolitical narratives, yet it is vital for recognizing the potential for human advancement through shared goals and exploration. 7. Public perception and support. The plans for a lunar nuclear reactor may provoke public and political reactions, particularly concerning safety and environmental implications. The significance here lies in understanding how public perception can influence governmental policies and international collaborations in space. The narratives surrounding nuclear energy, especially in the context of space, could shape future investments and international partnerships, highlighting the need for transparent communication about risks and benefits. In conclusion, while the announcement of a nuclear power plant on the Moon may appear to be a straightforward technological development, the underlying implications are multifaceted and deeply significant. From technological collaboration and geopolitical strategy to resource utilization and international cooperation, these factors will shape the future of lunar exploration and humanity's relationship with space. Recognizing these elements allows for a more nuanced understanding of not only the current plans but also their potential long-term impacts on global dynamics and the quest for sustainable living beyond Earth. 1. Nuclear power as a strategic solution for lunar exploration. The proposal to build a nuclear power plant on the Moon by China and Russia highlights the critical need for a reliable and long-term energy source to support lunar missions. Given the Moon's extreme environment, traditional power sources like solar may not suffice for sustained operations. The involvement of Russia with its advanced expertise in space-based nuclear technology adds a significant capability to this initiative. This collaboration could set a precedent for future energy solutions in space exploration, potentially leading to more ambitious missions beyond the Moon. 2. Timeline and milestones. The outlined timeline for the Chang'e 8 mission and the subsequent establishment of a lunar base by 2035 presents a clear framework for China's lunar ambitions. The strategic partnership with Russia, with plans for a nuclear reactor by 2035, underscores a coordinated approach to space exploration. This timeline aligns with global competitors, notably NASA's Artemis program, which aims for a sustainable lunar presence. Analyzing these milestones reveals the competitive landscape of international lunar exploration and the technological advancements required to achieve these goals. 3. International context and geopolitical implications. The collaboration between China and Russia on lunar exploration occurs against the backdrop of a new space race, particularly with the United States' renewed interest through NASA's Artemis program. This geopolitical dimension introduces concerns about space governance, resource allocation, and potential conflicts in lunar territories. The strategic importance of the Moon due to its resources and position for further space exploration adds layers of complexity to international relations, necessitating discussions on cooperation versus competition in space. For resource utilization and future implications, the Moon's potential resources, particularly rare earth metals and helium-3, could revolutionize energy production on Earth and in space. The establishment of a nuclear power plant would not only support lunar missions but could also facilitate the extraction and utilization of these resources. This aspect of the initiative raises questions about sustainable practices, the ethics of resource exploitation in space, and the long-term impacts on Earth's energy landscape. The implications of this endeavor could extend well beyond lunar exploration, influencing global energy strategies and international collaborations in space resource management. In summary, the China-Russia initiative to build a nuclear power plant on the Moon is not merely a technical endeavor but a complex interplay of energy needs, geopolitical dynamics, and resource exploitation strategies that will shape the future of space exploration and international relations. 1. The Manhattan Project, United States, 1942 to 1946. The Manhattan Project was a secret research and development project during World War II that produced the first nuclear weapons. Led by the United States with the support of the United Kingdom and Canada, this massive effort involved some of the greatest scientific minds of the time, including Robert Oppenheimer and Enrico Fermi. The project culminated in the development of atomic bombs that were dropped on Hiroshima and Nagasaki in August 1945.
leading to Japan's surrender and the end of World War II.
The project not only marked a significant technological advancement but also initiated a new era of nuclear power and energy which has lasting implications for international relations and military strategy. 2. The Apollo Program, United States 1961 to 1972. The Apollo program was a series of missions undertaken by NASA with the primary goal of landing humans on the Moon and bringing them safely back to Earth. The most notable mission, Apollo 11, achieved this goal in July 1969 when astronauts Neil Armstrong and Buzz Aldrin became the first and second humans to walk on the lunar surface. This program not only represented a significant achievement in space exploration but also showcased the United States' technological prowess during the Cold War, particularly in the context of its rivalry with the Soviet Union.
The Apollo missions laid the groundwork for future lunar exploration and significantly advanced scientific knowledge of the Moon. 3. The International Space Station 1998-present. The International Space Station ISS is a multinational collaborative project involving space agencies from the United States, NASA, Russia, Roscosmos, Europe, ESA, Japan, JAXA, and Canada, CSA. Launched in 1998, the ISS serves as a microgravity research laboratory where scientific research is conducted in astrobiology, astronomy, meteorology, and other fields. The ISS represents a significant achievement in international cooperation in space exploration and has provided valuable insights into the challenges of long-term human habitation in space. Its ongoing operation and maintenance demonstrate the potential for collaborative projects in addressing complex scientific and technical challenges beyond Earth. These historical cases highlight significant advances in nuclear technology and space exploration, showcasing the global race for power resources and technological supremacy.
The initiative by China and Russia to construct a nuclear power plant on the Moon to support the International Lunar Research Station (ILRS) marks a significant turning point in lunar exploration and energy production. This venture is set against the backdrop of a new space race with multiple nations vying for a foothold on the Moon. 1. Advancements in space collaboration and technology. As outlined by officials from both countries, the collaboration aims to leverage Russia's expertise in space-based nuclear technology, which could play a crucial role in establishing a sustainable energy source for the ILRS. With the Chang'e 8 mission scheduled for launch in 2028, this project is poised to lay the groundwork for a permanent lunar base by 2035. The adoption of nuclear power is particularly significant given the Moon's harsh environment, where solar power may be less reliable due to extended periods of darkness.
2. Timeline and milestones. 2024, initial announcements from Roscosmos regarding collaboration with China to develop a lunar nuclear reactor by 2035. 2025, official presentations highlighting the plans for the nuclear power plant, indicating high-level government support. 2028, launch of the Chang'e 8 mission, which will focus on energy generation and establish infrastructure for future lunar habitation. 2030 to 2035, target for completing the ILRS, facilitating long-term human presence and research on the Moon. 3. International dynamics and competition. The initiative comes amid a global resurgence in lunar exploration, with NASA's Artemis program aiming to return astronauts to the Moon by 2027. This competition underscores the strategic importance of lunar exploration and the potential for resource extraction. The U.S. is also exploring nuclear options for its lunar base, indicating a broader recognition of nuclear energy's viability in space. 4. Resource utilization on the Moon. The Moon is believed to harbor significant resources including rare earth metals and helium-3, a potential fuel for nuclear fusion that could address energy demands for millennia. The establishment of a nuclear power plant could not only support lunar missions but also pave the way for large-scale resource extraction, fundamentally altering humanity's approach to energy production and space exploration. 5. Future implications. If successful, the China-Russia nuclear power project on the Moon could lead to Sustainable lunar operations, a reliable energy source would enable continuous lunar missions, scientific research, and potential colonization efforts.
Increased global collaboration, the ILRS could become a hub for international scientific cooperation,
inviting participation from numerous countries and institutions.
Technological advancements, innovations stemming from the challenges of building and operating a nuclear facility in space could have broader applications on Earth, particularly in renewable energy sectors.
6. Potential challenges. Despite the optimistic outlook, several challenges must be addressed.
Regulatory and safety concerns. The deployment of nuclear technology in space raises safety and regulatory issues, necessitating international agreements and protocols to prevent potential disasters.
Technical feasibility. The engineering and technical hurdles involved in constructing a nuclear facility on the Moon are formidable and will require significant investment in research. Geopolitical tensions. The collaboration between China and Russia may exacerbate existing geopolitical tensions, particularly with Western nations. The strategic implications of a nuclear presence on the Moon could lead to an arms race in space. 7. Long-term vision. By 2035, if the ILRS becomes operational and the nuclear power plant is functional, we could witness a new era in human space exploration. The Moon could serve as a launchpad for missions to Mars and beyond, as well as a site for extensive research into the viability of extraterrestrial life and the sustainability of human life in space. In conclusion, the China-Russia initiative to build a nuclear power plant on the Moon represents not only a significant technological milestone but also a transformative step towards long-term human presence in space. As plans progress, the outcomes of this collaboration will shape the future of lunar exploration, international relations, and energy production, potentially reshaping humanity's place in the cosmos.